Hello,
Uh,
hello. Hello, hello. Okay, okay. Can you hear me? Yeah? Okay. Yeah. So, today we will continue with the chemistry revision. Yeah. Okay. Chemistry revision. Okay. Yeah. So we will continue with this worksheet. Okay, number 6. Okay, yesterday we were up to question 6. Okay. So now we will continue with question 7. Okay. Yeah. Okay, let me open a periodic table. Okay, we need a periodic table. Okay, and um, okay, um, okay. Okay, let's take a look at question 7. Okay, using the information from the table below. Okay, which of the following atoms will combine to form a covalent molecule? Okay, covalent molecule. Okay, so which means we want uh non-metal plus non-metal. Okay, yeah. So always useful to find out um what what element is it? Okay, what element is it? Yeah, so for covalent bonding, the number of neutron is not that important, so we don't need to consider that. We mostly look at protons. Okay, so 10 protons we'll see. Okay. Okay. Okay, 10 protons. Yeah, here. 10 protons. Neon. Okay, so we are looking at neon. Okay. Okay, this is neon. Okay, 6 protons. Okay, 6 protons. Carbon. Okay, so this is carbon. 17 proton. Okay, 17 and 11. 17 and 11. Okay, 17 is chlorine. Okay, 11 sodium. Okay, okay. So this is chlorine and then this is sodium. Okay. So neon is a noble gas, so it's not reactive. Yeah, so electron configuration 2,8 is not reactive. So we don't consider that. Okay. Um Sodium is a metal, group 1 metal with one covalent molecule, so we don't consider that. Okay. Yep. Yep. Okay. So either Q or R. Okay. So our answer will be B. Okay. R and R. So ClCl. Okay. Single bond. Okay. So this is a covalent molecule. Yep. Okay. Next. Substance W is made out of two different elements. W conduct electricity only in molten and aqueous states. Okay, only molten and aqueous state. So which means it is ionic compound. Okay, so W has high melting point and very soluble in water. Okay, so again, this is characteristic of ionic compound. So which one is substance W? Okay, so we see this one, hydrogen and sulfur, non-metal and non-metal. So this is covalent. Okay, so this no. HF non-metal, non-metal. So this is covalent. Okay, so this is no. Okay, AgCl, silver chloride. So this is metal plus non-metal. This is ionic. Okay, and potassium iodide, metal, non-metal. So this is ionic. Okay, so these are both ionic, no problem. Okay, so we can see here very soluble in water. Okay, so you will learn in later chapter that silver chloride is non-soluble. Yeah, okay. So it's non-water soluble. So although it's ionic compound, it's not our answer. Okay. Potassium iodide, yes, is soluble. Okay. So yeah, useful to remember anything starting with potassium is water soluble. Yeah, anything starting with sodium, potassium is water soluble. Okay. So this will be our answer. Okay, next. Which statement, okay? Which statement about ammonia is correct? Okay, ammonia. Okay, so ammonia, you may recall ammonia is NH3. Okay, so the formula is NH3. One nitrogen, three hydrogen. Okay, nitrogen atoms share electrons with three hydrogen atoms to attain stable electron arrangement. Okay, so we can check that. Okay. Yeah. Okay, nitrogen, okay, hydrogen, okay, proton, electron. Okay, hydrogen is 1, 1. Electron configuration is 1. Okay, nitrogen. Okay, here you can see 7. Okay, so 7 protons. Okay, yeah. So 7 proton, 7 electron. Electron configuration 2, 5. Okay, so 2, 5 means 5 outer electrons. Okay, so 5 outer electron. So hydrogen, it just need to add one more electron to get 2. Okay, electron configuration of 2. That is a full shell. Okay, nitrogen we want 2, 8. Okay, so it needs to plus 3, so it needs to share 3 electron and then in the process getting 3 electrons. Okay, so the most suitable arrangement will be like this. Okay, nitrogen and 3 hydrogen. Okay, so hydrogen, uh, so nitrogen will be 1, 2, 3, 4, 5. Okay, to start with, and then hydrogen will be 1, 2, 3. Okay, so in the end, hydrogen have 2 outer electron. Nitrogen will be 8. Okay, so the correct formula will be NH3. Must be NH3, cannot NH2 cannot, N2H2 cannot. Okay, so this is the only arrangement that will give the full shell stable electron arrangement. Yeah, okay, stable electron arrangement. Nitrogen sharing electron with 3 hydrogen. Okay, so yeah, okay, so this is correct. So this is the correct answer. So yeah. Okay, let's look at B. Ammonia exists as a gas at room temperature due to weak covalent bonds present between the atoms. Okay, so this is incorrect. Incorrect. Okay, let us quickly look at the notes. Okay, to find out. Okay, let's look at the notes. Okay. Um. Yes. Okay, hold on. Okay. Here. Okay, so we can see here. Okay. Yes. Okay, we can see the covalent bond. They are strong bonds. Strong covalent bond. So this one is the weak bond. Okay. The intermolecular forces, they are the weak bonds. Okay. So we have molecule, molecule, molecule. The intermolecular forces is the weak. Okay, coming back to our question. So it says weak covalent bond. No, it's weak intermolecular forces. Okay. Okay, ammonia is a good electrical conductor. When dissolved in water, it contains mobile electron. No. Okay. Covalent compounds, they are poor electrical conductors. Okay. Ammonia is insoluble in water and it has low melting point. Okay. So ammonia is actually soluble in water. Is soluble in water. So again, this is incorrect. Okay. So answer is A. Okay, number 10. Okay. We have some information about four substance. Okay. W, X, Y, Z. Okay. Yeah. Okay. What could substance W, X, Y, Z be? Okay, let's take a look. Yeah. So the easiest one, it will be the easiest one to um identify. It will be Y. Okay. So Y is metal. Okay, because high boiling point and then conduct electricity in solid state, conduct electricity when molten. Okay, so this is the characteristic of metal. Okay, characteristic of metal. So why it will be metal. Okay, why will be metal? So this is incorrect. Okay, this is incorrect. Okay, so we are left with um B and C. Okay. So another one. Okay, so Z, we will say that Z is ionic. Okay. So why we say Z is ionic? Because does not conduct in solid state, conduct when molten. Okay. So Z is ionic. So no, no. Okay. So again we are left with B and C. Okay, let's see. Next one. Okay. So this one, low melting point does not conduct, does not conduct. So this one will be covalent. Okay. Simple covalent because it's low boiling point. Okay. So this one will be giant covalent. Okay. Because does not conduct, does not conduct, and then high melting, high boiling point. Okay. So we'll see one by one. So Z is ionic. Okay. X is giant covalent. Okay. W is simple covalent. Okay. So silicon dioxide. Okay. If we come back to our notes. Okay. Silicon dioxide is giant covalent. Okay. Silicon dioxide is giant covalent. Okay. So this is no. Okay, so this is simple covalent, nitrogen, chlorine, fluorine. Okay, no problem. Okay, okay, giant covalent. Okay, so giant covalent, magnesium oxide. No, magnesium oxide is ionic. So graphite is giant covalent, but it conduct electricity in solid state. It conduct electricity in solid state. So this is also no. Okay, so we are left with diamond and silicon dioxide. So just now we already know that D is uh is eliminated. So our answer is C. Okay, so our answer is C. Okay, next one. Okay, question 11. Okay. Yep. Okay, so properties of substance Y. Okay, physical state at room temperature, it is a solid. Okay, electrical conductivity in molten state is conductor. In solid solution, okay, when it's in solid, it's non-conductor. So we know it should be ionic. Yeah, conductor in molten state, in solid state is not conductor. So this is ionic compound. So graphite is no. Okay. Graphite is giant, covalent. Okay, hydrogen chloride is non-metal plus non-metal. So this one is simple, covalent. Okay. Aluminium is metal. Okay. So our answer is magnesium oxide, MgO. Okay. So this is ionic compound. Yep. Okay. So this is ionic compound. One metal plus non-metal. Okay. So this is ionic compound. Okay, next. Which structure does not contain carbon atom bonded to other atoms by 4 covalent bonds? Okay. So we want carbon bonded, okay, 4 covalent bonds. Okay. So if we look at carbon, here, carbon is 6. Okay. So carbon is 6. Okay. Electron configuration, 2, 4. Okay. So it has 4 outer electrons. Okay. So it needs 2 plus 4 electrons to form 2A. Plus 4 electrons. So it will share 4 electron, get 4 electrons. So it will form 4 bonds. Okay. So usually, okay, usually carbon will form 4 bonds. Okay. Most of the time. Okay. So we'll see one by one. Okay. Okay. Let's look at diamond. Okay. Diamond. Our notes. Okay. Okay. So diamond, we can see one carbon bonded to another 4 carbon. Okay. So no problem. Okay. This is correct. Okay. One carbon to 4 covalent bonds. Okay. So next we will look at carbon dioxide. Okay. So how about carbon dioxide? Okay. So we'll look at oxygen. Okay. Oxygen is here. 8. Okay. Oxygen is 8. Okay. Okay. Electron configuration. Okay. 2, 6. Okay. So it has 6 outer electrons. Okay. So it needs to add 2 more. Okay. To get full shell. Okay. So it will share 2, get 2. So it will form 2 bonds. Okay. So oxygen wants to form 2 bonds. Okay. So for carbon dioxide, the most suitable arrangement will be like this. Okay. So carbon, okay, oxygen, oxygen, like this. Okay. Okay. So carbon, the atoms will be like this. Okay. 1, 2, 3, 4. Okay. And then for oxygen, it will be like this. Okay, 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, 6. Okay, yeah. So in the end, carbon got 8 electrons, oxygen got 8, oxygen got 8. Okay, so it works out in this arrangement. So carbon dioxide is always CO2. Okay, always. And then we can see here sharing two pairs of electrons. So we'll get like this. Yeah, okay. C double bond O. Okay, so this is carbon dioxide. Okay, so now we can see carbon, it formed 4 bonds. Okay, no problem. This is correct, form 4 bonds. Okay, how about methane? Okay, methane. Okay, so good to know methane is CH4. Okay, methane is CH4. Okay, so how does it work? Okay, hydrogen is 1. Okay, proton 1, electron 1. Okay, electron configuration 1. So it needs to get to 2. So it will share 1. Okay, get 1. So it will form 1 bond. Okay, so the most suitable arrangement will be like this. Okay. Okay, carbon. Okay, and then 4 hydrogen. Okay, 4 hydrogen. So carbon will be like this. 1, 2, 3, 4. Okay, and then hydrogen. Okay, so hydrogen will be like this. Okay, 1, 2, 3, 4. Okay, yeah. So it works out like this. Okay, so hydrogen end up with 2 electrons, the full shell. Carbon end up with um 8 electrons, the full shell. Okay, and then here we can see carbon form the 4 bonds. Okay, so this is what we want. Okay, so this is what we want. So this is also correct. Okay, how about graphite? Okay, so graphite, we can look at the notes. Okay, so graphite, actually each carbon, it form 3 bonds only. Okay, each carbon only 3 bonds. Okay, so each carbon has 4 outer electrons. Okay, each carbon having 4 outer electrons is only forming 3 bonds. So it has the free electrons. Okay, so it has 1 free electrons. Okay, for each carbon, 1 free electron. So that's why graphite has mobile electrons and then it can conduct electricity. Okay, so that is the main characteristic of the carbon. Okay, uh, for the graphite. So this one is 3 bond only. Okay, so we want does not contain 4 covalent bonds. So this one is 4. This is 4. This is 4. This is 3. So answer is B. Okay. Okay. 13. Element Y is found in period 2, group 7. Okay. Period 2, group 7. Okay. So we'll take a look. Okay. So the period goes like this. Period 1, period 2, period 3, okay, period 4, and so on. Okay, so this one, group 1, 2, okay. So this part is transition metals. Okay, transition metals. Okay, and then group 3, 4, okay, 5, 6, 7. Okay, so we want period 2, okay, period 2 here, okay, and then group 7. Okay, so what we want is actually fluorine. Okay, so fluorine is the element that we are looking for. Okay, So we are looking for fluorine. Okay. Proton number is 9. Okay. Fluorine. Okay. Proton 9, electron 9, electron configuration 2, 7. Okay. It's in group 7. It exists as a diatomic molecule. Okay. Diatomic molecule at room temperature. Okay. So we can check that. Okay. So now fluorine has 7 outer electron. Okay. 7 outer electron. So fluorine, it will bond like this. Okay. It will bond like this. Okay. So it's starting with 7 outer electron. 1, 2, 3, 4, 5, 6, 7. Okay. So it needs to go to 2, 8. So it needs to plus 1 electron. So it will share 1, get 1. So it will make 1 bond. Yeah, okay. So it will make a single bond. Okay. 1, 2, 3, 4, 5, 6, 7. Okay. And then another fluorine. 1, 2, 3, 4, 5, 6, 7. Okay. So in the end, we have FF single bond. F2. Okay. So this is what we call diatomic molecule. Okay. So what it means by diatomic molecule? 2 atoms. Okay. Diatomic means 2 atoms. So we have 2 atom molecule at room temperature. Yes. Okay. So this is correct. Okay. It forms ion with negative 1 charge. Yes. Yes. Because it needs one more electron. It needs one more electron. So it will accept 1 electron. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so basically it will accept 1 more electron to get a full shell. Okay, negative 1 charge. Okay, so this is also correct. Okay, it reacts with non-metal by sharing one of its electron. Yes. Okay, so it will share 1 electron only because it only needs 1 more. Okay, it needs 1 more. Okay, sharing 1 electron. Yes. Okay. React with sodium to form giant ionic compound NaY2. Okay, NaY2. Okay. So let's see. Okay. Sodium. Okay. Let's check. Okay, sodium is here 11. Okay. 11. Proton number 11, electron 11. Electron configuration 281. Okay, so it has 1 outer electron. Okay, so it has 1 outer electron. Okay, so what will it do? Okay, so sodium. Okay, 1 outer electron. Okay, so this 1 outer electron will transfer to the fluorine. Okay, so it will transfer to fluorine. Okay, so it will form, okay, plus 1 ion because it loses 1 electron. Okay, it loses 1 electron, so it will form plus 1 ion. Okay, so Na plus F negative, so the formula will be 1 to 1, NaF. Okay, NaF. So this one NaY2, NaF2, no, it's wrong. It's NaF. Okay, so the answer is B. Okay, answer is B. Okay, next. Okay, so which molecule? Okay, on. Okay, which molecule all the outer electrons involved in covalent bonding? All the outer electrons involved in covalent bonding. Okay, so we can check one by one. Okay. Um. Okay, hydrogen sulfide. Okay, hydrogen sulfide. Okay, so let's look at hydrogen first. Okay, hydrogen is 1 proton, 1 electron. Okay, so it needs to get to 2, so it will plus 1. Okay, so it will form 1 bond. Okay, sulfur. Okay, okay, sulfur is here. Yes, 16. Okay, so sulfur is 16. Okay, okay, 286. Okay, so it needs to get to 288. Okay, so it needs 2 more electrons. Okay, so what it will do? It will share 2, get 2. So it will form 2 bonds. Okay, like this. 1, 2, 3, 4, 5, 6. Okay, so hydrogen sulfide, it will be like this. Okay, uh, okay, hold on. Sulfur in the middle, and then hydrogen like this. Okay, so sulfur will be 1, 2, 3, 4, 5, 6. Okay, so it will form 2 bonds. Okay, and then hydrogen will be form 1 bonds like this. Okay, so now total we have 2, 2, 8, right? 2, 2, 8. Okay, but total, if we just add up all the electrons together, it is 8 electrons. Okay, it's 8 electrons. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. Okay, looking at hydrogen is 2, looking at hydrogen is 2, looking at sulfur is 8, but if we just count the total, it's 8. Okay, so this 8 electron is, okay, 4 of them is bonding. Yeah, so they are in the bonding. Okay, and then another 4, this one, okay, non-bonding. Okay, so they are not inside the bond. Okay, so okay, so this one will be for bonding. Okay, for non-bonding. Okay, so we want all bonding. Okay, we want all bonding. So this is no. Okay, so this is no. Okay, how about NH3? Okay, NH3. So just now we already did this example. Okay, nitrogen and hydrogen, it will go like this. Okay, hold on. Okay, nitrogen and hydrogen, it will go like this. Okay, so it will go like this. Okay, nitrogen, 5 outer electrons. 1, 2, 3, 4. Okay, and then hydrogen, okay, 1 outer electron. Okay, 1, 1, 1. Okay, yes. So now hydrogen is 2, 2, 2. Nitrogen is 8. But if we actually count the total electrons, it's still 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Okay. Now we will see. Just now this one is for bonding, for non-bonding. Okay. So now we will check. Bonding is 1, 2. Hold on. Okay. So this one is non-bonding. Okay. Non-bonding is 2. Okay, so 2 non-bonding, and then bonding. Okay, 1, 2. Okay. Yes. Okay. Bonding is 1, 2, 3, 4, 5, 6. Yeah. Okay. So bonding 6. Okay. So for the ammonia, okay, 6 bonding, okay, 2 non-bonding. Okay, so this is no. Okay, HBr. Okay, HBr. Okay, so Br, if we look at the periodic table, okay, Br is here. Okay, so it's got lots of electrons. Okay, so it's a little bit tricky for us to work out the electron configuration. What we need to know is Br in group 7. Okay, that's all we need to know. Br in group 7, it has 7 outer electrons. Okay, so Br has 7 outer electrons. Okay, so it will be like this. Okay, okay. Br has 7 outer electrons. 1, 2, 3, 4, 5, 6, 7. Okay, and then hydrogen, it will be like this. Okay, so hydrogen will be 2, bromine will be 8. Okay, so but the total electron, it will be um 8. Okay, so now we'll look at the bonding, non-bonding. Okay, so the bonding will be just here. Okay, so bonding, okay, 2. Okay, non-bonding. Okay, hold on. Okay, non-bonding, 1, 2, 3, 4, 5, 6. Okay, okay, non-bonding will be 6. Okay, so this one is 2 bonding, 6 non-bonding. Okay, okay, how about CH4? Okay, CH4. So just now we already know carbon, it has 4 outer electrons. Okay, so carbon is in group 4, so it has 4 outer electrons. Okay, so the best arrangement will be like this. Okay, yes. Okay, so carbon 1, 2, 3, 4. Okay, and then hydrogen like this. Hydrogen only 1 outer electron. Okay, yep. So hydrogen will be 2, 2, 2, 2. Carbon will be 8. Okay, but if we count again, the total is 8. Okay, total is 8. Okay, so now we'll check the bonding. Okay, the one that is in the bond. Okay, 1, 2, 3, 4. Okay, 5, 6, 7, 8. Okay, so we can see bonding. Okay, so 8 bonding electrons. Okay, so how about non-bonding? Okay, so non-bonding, we can see here, this is 0. Okay, so we don't have any bonding electron. Okay, non-bonding electron is 0. Okay, so which means this one is all bonding. Okay, so all the outer electrons, they are involved in the covalent bonding. Okay, so our answer will be C. Okay, so that is the concept for this question. Okay, okay, which substance is macromolecule? Okay, macromolecule. Okay, macromolecule means is large molecule. Okay, large molecule. So okay, if we look at macromolecule, so diamond and graphite, they will be macromolecule, and then um silicon dioxide also. Okay, so these are macromolecule. Okay, so they are a large molecule. Okay, so these ones, okay, these ones they are simple molecule. Okay, so these are simple molecule. Okay, so the molecules they are quite small. Yeah, only 3 atoms. Okay, so this is simple molecule, only 4 atoms. Okay, so these are small molecules, simple molecule. Okay, so this is giant molecule. Okay, giant molecule because one molecule can make up of millions. Okay, millions of atoms. Okay, lots and lots of atoms. Okay, so okay, nitrogen dioxide. Okay, nitrogen dioxide is um NO2. Okay, one nitrogen, two oxygen, nitrogen dioxide. Methane is CH4. Okay, sulfur dioxide is SO2. Okay, SO2. Um, okay, so our answer is silicon dioxide. Okay, macromolecule. So this is simple, simple, simple. Okay, simple, simple, simple. Okay, silicon dioxide. Okay, is this SiO2. Okay, so this is a macromolecule or giant covalent structure. Okay, so our answer is silicon dioxide. Okay, yep. Okay, macromolecule. Okay, yeah. So at this point, it will be quite useful. Okay, quite useful to for practice purpose. Try to work out the dot and cross diagram. Okay, dot and cross diagram. So methane, we already know how to do it. Okay, methane is like this. Okay, how about NO2? Okay, how about NO2? Okay, so how does it work? Okay, and then sulfur dioxide. Okay, sulfur dioxide. Okay, let me just get a quick picture. Okay, um, okay, okay, okay. Yep. Okay. So a okay. Nitrogen dioxide, it looks kind of like this. Okay. Yeah, nitrogen dioxide. Okay. So this is the dot and cross diagram. Okay. For the nitrogen dioxide. Okay. Yeah. Okay. Yep. Looks like this. Okay. And then how about sulfur dioxide? Okay. Sulfur dioxide. Okay. Um, okay. Okay, let's see. Uh, okay, so sulfur dioxide is like this. Okay. Yep. Okay. Yep. Okay. So nitrogen dioxide and sulfur dioxide, they are actually more complicated. So for IGCSE, we don't really need to know how to do it, okay? But in A levels, you need to know how to do it, okay? So they are more complex situation. Okay, next. Okay, which statement about water molecule is correct? Okay, which statement about water molecule is correct? Okay, so now water, what is the structure of water? Okay, so oxygen. So first we start with oxygen. Okay, so the structure is kind of like this. Okay, okay, so first we'll look at oxygen. Oxygen in group 6. Okay, in group 6. So it has 6 outer electrons. Okay, 6 outer electrons. Okay, so 1, 2, um, okay, let's do it like this. Okay, 1, 2, 3, 4, 5, 6. Okay, so it's got 6 electrons, so it only need to form 2 bonds. Okay, it only need to share 2 electrons. Okay, so hydrogen is 1, 1, 1. Okay, so that's why water is always H2O. Okay, so this is the arrangement that will give the full shell 8, 2, 2. Okay, each hydrogen donate a pair of electron to the oxygen. No, so this is covalent compound. Okay, non-metal and non-metal. So we don't have donate electron. No, okay, it's electron sharing. Okay, so it's not donate. So A is not correct. Okay, how about D? Each hydrogen atom transfer 1 electron to oxygen. Transfer? No. It is electron sharing. Okay. The oxygen atom form double covalent bond with hydrogen. No. It's single bond. Okay. It's single bond. It's just sharing of 1 pair of electron on each side. Okay. No. This is single. Okay. So this is no. Okay, there are 2 single covalent bond between oxygen and hydrogen. Yes, 2 single bond. Okay, so answer is B. Okay, okay, next. Which element forms a stable ion? Okay, form a stable ion. Okay, let's see. Okay, it form a stable ion with the same electronic arrangement as neon. Okay, same electronic arrangement as neon. Okay, let's see. Neon. Okay, neon is here. Okay, so neon has 10 protons. Okay, proton 10, electron 10, electron configuration 2, 8. Okay, so neon will be like this. Okay, 2, 8. Okay, yep. Okay, so it will form a stable ion. Okay, stable ion. Okay, so we can start with okay, so first we will list out the number of proton, number of electron. Okay, on. Okay, okay, number of proton, number of electron. Okay, electronic configuration. Okay, so what kind of ion it will form? Okay, what kind of ion it will form? And then okay, so this one is electron configuration of the atom. Okay, and then we'll look at electron configuration of the ion. Yeah, okay. So we'll check one by one. Okay. Yeah. Okay. Yes. So first we look at the atom situation. Okay, beryllium. Okay, beryllium is here. It's 4. Okay. So 4. Okay. Lithium 3. Okay. Lithium is 3. Okay. Phosphorus. Okay, here 15. Okay. Phosphorus is 15. Okay. Fluorine. Um okay. Fluorine is here. Okay. Fluorine is 9. Okay. Okay. Number of electron, same as number of proton. Okay, electron configuration, it will be 2, 2, 2, 1. Okay, phosphorus is 2, 8, 5. Okay, fluorine is 2, 7. Okay, so beryllium, okay, so beryllium is in group 2. Okay, so it's in group 2. So it will lose. Okay, so it will lose the 2 electron to form beryllium 2 plus ion. Okay, so lithium will lose the outer electron to form lithium 1 plus ion. Okay, and then the phosphorus, it will add 3 electrons. Okay, it will add 3 electrons to give phosphorus 3 negative. Okay, fluorine will add 1 electron. Okay, to give fluorine negative 1. Okay, so now the electron configuration will be 2, 2 for the ion. So this will be 2, 8, 8. Okay, adding 3 electron. So this will be 2, 8. Okay, so the one that is same as neon, the one that is same as neon is the fluorine. Yeah, okay. So after it formed the ion, okay, having same electron configuration as the neon. Okay, so this is how we work out the answer. Okay. Okay, correct structure of calcium carbonate. Okay. Calcium carbonate, this is metal. This is non-metal. Okay. So means this is ionic compound. Okay. Uh, okay, giant metallic lattice. So this is metal. No. Okay, so simple molecular structure. This is covalent. Okay, no. Giant covalent structure. So this is also covalent. No. Okay, so we want ionic, giant ionic structure. Okay, so this is the one. Okay, next. Which statement is correct about the compound formed when aluminium reacts with oxygen? Okay, aluminium reacts with oxygen. Okay, so now we can see aluminium is 283. Okay, oxygen is 26. Okay, so what will happen is, okay, we have aluminium. Okay, it will lose 3 electrons to form aluminium 3 plus. Okay, oxygen, it will accept 2 electron. Okay, to form oxygen 2 negative. Yeah. Okay, so to get the full shell. So now both of them have a full shell. Okay, so now to balance the charge, it will be like this. Okay, plus 6, negative 6. So the correct formula will be Al2O3. Okay, so formula ALO, this is incorrect. Al2O3. Okay, conduct electricity in molten state. Okay, so this is ionic compound. In molten state, it can conduct electricity. Okay, yes, correct. Okay, molten state, it can conduct electricity. Okay, so this is correct. Okay, lower boiling point. Okay, low boiling point. No, it is high boiling point. Okay, ionic compounds, they have high boiling point. Okay. Malleable and ductile. So this is talking about metals. Okay. So this is ionic. So this is not. Okay. So our correct answer is B. Okay. Conduct electricity in the molten state. Okay. Next. Okay. So cross section of electrical cable. The cores is made out of thin iron rods which are covered with layer of PVC. Okay. Okay. Which statement are correct? Okay. Okay. Which statements are correct? Okay. So here we are focused on metal. Okay. So we are focused on the characteristics of metals. Okay. So metals, they have the characteristics that are suitable, okay, for making cables. Okay. So metals are suitable for making cables because of their um unique characteristics. Okay. Um okay, we'll see one by one. And then PVC is plastic. Okay. So it's insulator. So it's useful to be used as the outer covering. Okay. So it's useful to be used as the outer covering. Okay. PVC protect the iron from corroding. Yes. Okay. So it's act as an outer protection. The mobile electrons in iron travel along the iron to conduct electricity. Yes. Okay. So looking at the notes. Yeah. Okay. Yes. So metallic bonding. So iron is a metal. So it will form metallic bonding. Okay. So it will form metallic bonding. So um the metals, they have these free electrons. Okay. So the C of the localized electrons. Okay. Free electrons that can help them conduct electricity. Okay. Correct. Okay. Okay, PVC, a good insulator, it does not contain free ions to conduct electricity. Okay, so it's good. So it can act as a good insulator. Okay, so number 3, it is also correct. Okay, so number 4, okay, number 4, iron is soft, which allow it to be easily drawn into rods. Okay, which allows it to be easily drawn into rods. Okay, so this one, what is the characteristic we're talking about? Okay, so for it to be drawn into rods is ductility. Yeah, okay. So this characteristic is what we call ductility. Okay. So the correct terminology is not soft, is ductility. Okay. So the correct answer will be 1, 2, 3. Yes. Okay. The correct statements, they are 1, 2, 3. Okay. Next. Okay, diagram show incomplete electrical circuit. Which substance causes the lamp to light when added to the glass tube? Okay, so which one we should put here so that it conduct electricity? Okay, so aqueous sugar. Okay, so sugar is covalent compound, so it does not conduct electricity. No. Okay, sodium chloride is ionic. Okay, metal plus non-metal is ionic. But in solid state, it does not conduct electricity. No. Okay. Liquid ethanol. So ethanol is like this. Okay. So this is the molecule of ethanol. So again, this is a simple covalent compound. Okay. So this is a simple covalent compound, does not conduct electricity. Solid graphite, yes. Okay. Solid graphite can conduct electricity. Okay. So as we mentioned before, yes. Okay. Graphite has free electrons. Okay. Next. Which compound contains both ionic and covalent bonds. Okay, both ionic and covalent bond. So this one, iron chloride, this is ionic only. Okay, ionic only. Silicon dioxide, this one is giant covalent. Okay, so this one is covalent bond only. Okay, glucose. Okay, so we can see non-metal, non-metal. So they are all non-metal. So this is covalent only. Okay, covalent bonding. Ammonium chloride. Okay, ammonium chloride. So ammonium is like this. NH4 ion. Okay, chloride ion like this. Okay, so they too will form ionic bonding, positive and negative charges. Okay, they will form ionic bonding. And then inside the ammonium is like this, ammonium. Okay, ammonium. Okay, so this one is covalent. Okay, so this is covalent bonding. So they have both covalent and ionic. Okay, ammonium chloride. Okay, next. A science article contains the following statement about a substance. Okay, so it's hard and stronger than steel and melt at very high temperature. Is not conductor of electricity, which substance in being described. Okay. Um, is hard and stronger than steel and melt at very high temperature. Okay. So non-conductor. Okay. Non-conductor means it's not a metal. Okay. Not metal. So means copper is no. Okay. Magnesium, uh, graphite also no, because graphite is a conductor. Okay, so it's not a conductor. Okay. Stronger than steel and melt at very high temperature. Okay. So it's a non-conductor of electricity. So this one is conductor when molten. Okay, or aqueous. Non-conductor is when it is solid. Okay, so this one is solid. Okay, molten is both non-conductor. Okay, and it's very strong. Okay, and melt at very high temperature. So our answer is diamond. Okay, non-conductor of electricity under any condition. Okay, so that is diamond. Okay, carry on. Okay, next question. Okay, what is the formula of the ionic compound when calcium and nitrogen react? Okay, calcium. Okay, if we look at periodic table, calcium is group 2. Okay, so group 2 meaning it will form 2 plus ion. Okay, so whenever we see group 2, we know that it will form 2 plus ion. Okay, nitrogen. Okay, nitrogen is group 5. Okay, so nitrogen is group 5. So what does it mean? Okay, nitrogen is 7 proton, 7 electron, electron configuration, 2, 5. Okay, 2, 5 means it needs to plus 3 electrons to get to 2, 8. Okay, so it needs to plus 3 electrons, so means it will form 3 negative. Yeah, so it will form 3 negative ion. Okay, so which means we need calcium, 3 of them. Okay, nitrogen, 2 of them. Okay, so that will give us plus 6, negative 6. Okay, so our answer will be, okay, so our answer will be Ca3N2. Yes, okay, so Ca3N2. Okay, which statement about the physical properties of substance is incorrect? Okay, incorrect. So we'll see. Metal are solid that conduct electricity, no problem. Okay, simple molecular compound have lower melting point than ionic compound. Okay, it's correct. In general, they have lower melting points than ionic compound. Okay, ionic solids, they are always brittle. Okay, yes, ionic solid, they will break like a glass. Okay, so they are brittle. Yes. All metals have low density. No. Metal, they are generally quite heavy. Okay, so they generally have quite high density. Okay, so they have high density. Okay. Next. Okay, so next we will move on to structured question. Okay, we'll move on to structured question. Okay, copper is commonly used to make electrical wires due to its good electrical conductivity. Okay, so it is a metal. Okay, copper is a metal. Okay, next, describe with the aid of a diagram the arrangement of particles in copper. Okay, the arrangement of particles in copper. So, which means we need to draw metallic bonding. Yeah, okay. So we need to draw metallic bonding. What does it look like? Okay, so it's kind of like this. Okay, metallic bonding is kind of like this. Okay, so how can we draw a simple diagram? Okay, in the exam situation, how can we draw a simple diagram? Okay, so we'll draw something like this. Okay, yes. So positive ions and then a sea of electrons. Okay, positive ions in a sea of electrons. Okay, yes. Okay, description, regular arrangement of cations in a sea of delocalized electrons. Okay, so this is the complete description that we need to give. Okay, next. Explain why copper is a good conductor of electricity. Okay, so why copper is a good conductor of electricity? Okay, because it contains the localized electrons that are free to move. Okay, so the free electrons, they are available to conduct electricity. Yep. Okay, next. Another property that copper that makes it suitable to be made into electrical wires. Okay, so if we want to make it into electrical wires, we need two conditions. Okay, so first, it must be a good conductor of electricity. Yes. Secondly, is the property, is this property here, ductility. Okay, ductility, we must be able to make them into the shape of wire. Okay, we must be able to make them into the shape of wire. So this ductility characteristics is important. Okay, so our answer, it is ductile, and that it can be drawn into wires. Okay, next, suggest a method to increase the hardness of pure copper. Okay, increase the hardness of pure copper. So normally, how do we make it harder? Okay, we make into form an alloy mixture with another metal. Okay, normally when we make it into an alloy, the hardness will increase. Okay, so to understand this better, we can take a look at the notes quickly. Yeah, okay. Okay. Um, okay, hold on. Okay, no, no, it's not that. Let me quickly find a picture. Uh, yes, this one. Okay, okay. Now we try to like understand, okay, why alloy have they are harder. Okay. Okay. Yep. Okay. So if we look at pure metal, okay, pure metal, the atoms can slip past each other. Okay. So if we apply a force, the metal, they can slide past each other, no problem. Okay. But if we have alloy, okay, alloy means we have atom of different size. Okay. So let's say this is 100% iron. Okay, so this is 100% iron. So maybe we have like uh 95% iron, and then 4% carbon, 1% nickel. Example. Okay, so we have this like big atom and small atom. So when we apply the force, it cannot move easily. Okay, so the atoms cannot move easily. So which makes it harder. Okay, so that's the characteristic of alloy. Okay, next. Magnesium oxide melts at 2850 and then is often used to line the inner surface of furnace. Draw the dot and cross diagram to show the bonding of magnesium oxide. Okay, yeah, so this is another common exam question. Okay, this is another common exam question. Okay, so how do we start from scratch, okay, to create the dot and cross diagram of magnesium? Okay, so if we don't know where to start, we start with the atom. Okay, so we start with the atom. Okay, magnesium, oxygen. Okay, proton, electron, proton, electron. Okay, magnesium, here, 12. Okay, magnesium is 12, oxygen is 8. Okay, 12, 8. Okay, 12, 8. Okay, so now electron configuration 282. Okay, this one electron configuration 26. Okay, so it's telling us that magnesium, it needs to lose 2 electrons to get the full shell. So oxygen need to plus 2 electrons to get the full shell. Yeah, okay. So what we expect to happen is like this. Okay, hold on. Okay, magnesium. Okay, 2 outer electrons on the magnesium. Okay, and then oxygen, which is having 6 outer electrons. Okay, so oxygen is 6 outer electrons. Okay, so now the electrons from magnesium will go to oxygen. Okay, so magnesium losing 2 electrons, losing 2 electrons. So the outer shell is empty, no more. Okay, so it just look like this. Okay, so for the magnesium. Okay, and then for the oxygen, it will be like this. Okay, oxygen. So it started with the 6 electrons that it has. Okay, and then in the end, it also received 2 electrons from the magnesium. Okay, so the charge is -2. Okay, because it received 2 electrons. Okay, so that is the idea. Okay, so basically this is the answer. Okay, so this is the answer. Okay, yeah, so in the exam situation, we just need to show the outer shell. Okay, so most of the time we just need to show the outer shell. Okay, but sometimes it is possible if it asks for all the shells. If it asks for all the shells, we will draw like this. S. Okay, so magnesium in the end is 2,8. Okay, and then oxygen in the end is 2,8. Okay, 2 electrons coming from the magnesium. Okay, so this one is just the outer shell, also correct. If we draw all the shells, it is also correct, no problem. Okay, but normally in the exam, we just need to draw the outer shell. Okay, the inner shell, we don't need to draw it. Okay, explain in terms of structure and bonding why magnesium oxide has a high melting point. Okay, why magnesium oxide, why ionic compounds, they have high melting point. Okay. Okay, so this is because we form the oppositely charged ions. Okay, we form these ions with opposite charge. Oppositely charged ions, they are held together by strong ionic bond. Okay, so they are attracted. Okay, electrostatic attraction. Okay, held together by strong ionic bonds. So a large amount of energy is required to overcome or break the ionic bonds. Okay, so there are millions and millions of these bonds, these attractions. So we need lots of energy to break the ionic bonds. Okay, that's why it has high melting point. Okay, yeah. So looking at our notes. Okay, okay, so this giant ionic structure, okay, strong electrostatic forces of attraction. So we need lots and lots of energy to break this bond, okay, to melt this ionic structure. So that's why melting point is high, okay. Predict if solid magnesium oxide is electrical conductor. Explain your answer, okay. Is it electrical conductor? Okay, let's see. It's not, because the ions, they are not free to move. There are no mobile ions to conduct electricity. It's no. Okay. So this one we are talking about solid state. Okay. But if we melt it, molten, it can conduct. Okay. So if solid magnesium oxide, no. Okay. Non-conductor. Okay. Yep. So these are the key points we need to include to get the full marks. Okay. Next. Graphite is commonly used as lubricant in machinery and inert electrodes in electrochemical cells. Okay. So explain in terms of structure and bonding why graphite is used to lubricate machinery. Okay. Yeah. So we have learned about this. Okay. Yeah. This. Okay. There are free electrons in the graphite, and then so we have weak intermolecular forces. Okay, weak intermolecular forces. Okay, between the layers. Okay, so when we push the layers, they can slide over each other. Okay, so they can slide over each other. So graphite is soft because of the weak intermolecular forces between the layers. Okay, so because of that, it can be used as lubricant. Okay. Yep. Okay. So the key points. Okay. The hexagonal layers of the carbon atoms, they are held together by weak attractive forces. Okay. This one. Okay. Weak attractive forces or weak intermolecular forces, both acceptable. Okay. The layers can slide easily over one another. Okay. The layers can slide. Okay. So the graphite can be used as a um, used in the lubricate, used to lubricate machinery. Okay, next, state another property of graphite that makes it suitable to be used as a machine lubricant. Okay, what could be another important property? Okay, the answer is this. Okay, it has high melting point and able to withstand high temperature. Okay, because the machine is constantly moving, so it generates a lot of heat. Okay, so for the graphite to be used um, properly, it also needs to have a high melting point. Okay. Explain why graphite is used as electrode in electrochemical cells but not diamond. Okay. Why it can be used as an electrode. Okay. In electrochemical cells. Okay. Let me just find a picture. Electrochemical cell. Yes, yes. Okay, hold on. Okay. Electrolysis. Okay. Let me find a picture. Okay. Yep. Okay. So this is electrochemical cell. Okay. Electrochemical cell, we need electrodes. Okay. So we need the electrode to conduct electricity. Okay. So we need the electrode, cathode and not the electrode to conduct electricity. We will use graphite. That is because graphite can conduct electricity. Yeah, okay. So graphite is an electrical conductor. It has delocalized electrons. Okay, so we will use graphite. Diamond is a non-conductor. It has no delocalized electrons or it has no free electrons. Okay, so that's why we will use graphite, okay, as electrodes. Okay. Next. Okay, state an application of diamond. Okay, so what do we use diamond for? Okay, so it depends on the properties of the diamond. Okay, so diamond properties, it is hard. Okay, because all bonds are strong bonds. Okay, so which means it can be used as cutting tools due to the hardness and strength. Okay, yep. Application of diamond. Yep. Abrasive cutting tools. Next. Iodine has electron arrangement of 28887. Okay. So 28887. So normally we just look at the outer shell. Okay. Because the outer shell is the one that involved in chemical bonding. So inside is not that important. Okay. So if we look at iodine, it's here. Okay. Iodine is in group 7. Okay. Iodine in group 7 means it has 7 outer electrons. Okay. 7 outer electrons. Yep. So it's kind of like this. Okay. It has 7 outer electrons. Okay. So iodine exists as diatomic molecules and it is a solid at room temperature. Draw a dot and cross diagram. Okay. So iodine has 7 outer electrons. So it only need one more. It only need one more electron. So it will share one electron, get one electron. So it will form one bond. Okay. So another, okay, iodine, 1, 2, 3, 4, 5, 6, 7. Okay. So these two atoms, I mean these two electrons, they will share electron sharing to form the covalent bond. Okay. So it looks like this. Okay. The dot and cross diagram looks like this. Yeah. Okay. Yep. So in the end, we will form like this, okay, which is I2. So this is what we call diatomic molecules, okay, made up of two atoms, okay. So you don't have I3, I4, I5, no, okay, only I2, because I2 will end up with full shell for both of them, okay. Next, astatine. Astatine is element below iodine in the periodic table. Explain why it also has a low melting and boiling point. Okay. Yeah. Okay. So okay. Let me just copy this. Okay. Okay. So this is group 7. Okay. So this is all the group 7 um elements. Okay. Group 7 elements. We can see. Okay. Group 7 elements. Okay. So these are the group 7 elements. We have fluorine, chlorine, bromine, iodine, and this astatine. Okay, like this. Okay, so we have 1, 2, 3, 4, 5. Okay, so they are all in group 7. They all have 7 outer electrons. Okay, so we can see here when this iodine it has 7 outer electron, it will form this I2. Okay, so which is telling us whenever you have 7 outer electrons, you will always form this diatomic molecule. So you will form F2, Cl2, Br2, okay, I2, and astatine 2. Okay, so they all will form this diatomic molecules. Okay, so they are all simple. Okay, simple covalent compounds. Okay, so what's the characteristic of simple covalent compound? Okay, looking at our notes. Okay, simple covalent compound. This. Yeah. Okay. So simple covalent compound. Yeah. Okay. So simple covalent compound, they have weak intermolecular forces. Weak intermolecular forces. Okay. Because of that, they will have low melting and boiling points. Okay. So this is the main point. Okay. Yep. Why they have low melting and boiling point? Because of the weak intermolecular forces. Okay. Yep. Because it forms a covalent compound, weak attractive forces between the molecules. Okay, like what we mentioned just now, weak intermolecular forces. Okay, which can be overcome easily. Okay, so this bond can be broken quite easily. But the strong covalent bond is not easily broken, but the weak intermolecular forces can be broken easily. So that's why they have a low melting point and low boiling point. Okay. Yep. Okay. Next, iodine react with metal such as sodium. Okay. Sodium, iodine. So this will be ionic compound. Okay. Describe the formation of an ionic bond in the sodium iodide and draw a dot and cross diagram of the compound. You only need to show the outer shell. Okay. So again, if we don't know where to start, we always start with the ions. Okay. We always start with the ions. I mean, start with the atoms. Okay. So iodine, we know, is in group 7. So which means it has 7 outer electrons. Okay. 1, 2, 3, 4, 5, 6. 7. Okay. Sodium. Okay. Sodium in group 1. Okay. So sodium in group 1. So means it has one outer electron. Okay. One outer electron. Yes. Okay. So what will happen? This one electron will be transferred to the iodine. Okay. So transfer to the iodine. So we end up with sodium. No more outer electron. And then plus one charge, losing one electron. Okay, so now the iodine. Okay, so just now, 7 electrons that is belong to the iodine. And then now we add, okay, 1 electron that is coming from the sodium. Okay, so now the charge is -1. Okay, so that is the concept of this ionic bond. Okay, yep. Okay, so this is what we expect to draw. Okay, and then, so how can we describe this process? Okay, how can we describe? So basically, we have sodium atom transfer 1 electron to iodine. Okay, because of that, both will achieve stable electron configuration. Like sodium, it starts with 281, losing the electron. In the end, is 28. Yeah, okay. And then now the sodium also has a full shell. Okay, and then we form the sodium ion and the iodide ions. Because of the different charge, they will attract each other to form ionic bonds. Okay, so this is how we describe it. Okay, next. Okay, when potassium burns in chlorine, potassium chloride is formed. Okay, potassium chloride. So basically, this is ionic compound. Yeah, one metal and one non-metal. Okay, so potassium chloride lattice. Okay, no problem. Identify and describe the bonding in potassium chloride. Okay, we know that this is ionic bonding. So first, we state that it's ionic bonding, and then we explain what is ionic bonding. It's electrostatic attraction between the oppositely charged ions. Okay, the ions with opposite charge, they will attract each other. Okay, state the formula for potassium chloride. Okay, so potassium periodic table is in group 1. Okay, group 1 means it will form +1 ion. Okay, it will form +1 ion. Chloride, okay, chloride is in group 7. Okay, it is in group 7. Okay, if group 7, it will always form -1. Why? Okay, chlorine is 17 electron configuration 287. So it will always add 1 electron to get 288. So it will become -1, the charge. Okay, all group 7 will become -1. Okay, so +1, -1. So the formula is simply 1 to 1. Okay, just KCl. Okay, next. Why solid potassium chloride does not conduct electricity? Solid. Okay, so we know solid ionic compound does not conduct electricity. Okay, we know that. The reason? The ions are held in fixed position. Okay, so they are not free to move to conduct electricity. They are not mobile. Okay, they are not free to move. Okay, next. So here we have a tungsten light bulb. Okay, so this is a metal. Okay, draw a diagram to show the arrangement of particles in a tungsten metal. Explain why it is a good conductor of electricity. So again, we need to draw about metallic bonding. Okay, so metallic bonding, what it looks like. Okay, we discussed before. Metallic bonding like this. Yeah, okay. Description. Okay, why it is a good conductor? It has delocalized electrons that are free to move, that can carry charge throughout the structure. Okay, so that's why we say that um, metals, they are good conductor of electricity because of these three key points. Okay, carry on. Okay, tungsten has a very high melting point, 3422. Explain in terms of bonding why tungsten has a high melting point. Why it has a high melting point? Because we have attraction between the positive ions and the electrons. We have strong attraction, positive ion and negative electrons. Okay, we have the strong attraction. Okay, yep, that's why it has metals. They normally have high melting points. Okay, there is strong electrostatic forces of attraction between the positive metal cations. Okay, let me let me copy. Yep. Okay. So strong attraction, okay, between the positive ions and the C of the localized electrons in the lattice structure. Yeah, okay. Because of the strong electrostatic attraction. Okay. Millions and millions of the attraction. Okay. So that's why metals generally they have high melting point. Okay, tungsten metal is drawn into fine wires which are coiled together to form the filament of the light bulb. Explain why tungsten is ductile. Okay, yeah. So basically, it can drawn into wire to form this filament. Okay, so we know that it's because of the ductile. Okay, the ductile property of the tungsten metal. Okay, so this is the key point here. Ductile, okay? Why? Because it can be drawn into wire without breaking. That is the key point. Okay, we apply the force, it can slide, but it does not break. Okay, so that is the key point. Drawn into wire without breaking. Okay, so this is very important. Okay. Why it is ductile is because of this. Okay, the layers of atom they can slide over each other without breaking the metallic bond. Okay, without breaking the metallic bonding. Okay, yep. Okay, the cations in the structure they can slide across each other without breaking the metallic bonds due to the presence of the localized electrons. Okay, so the electrons are always there to hold them together. Okay, to hold the ions together so they can slide over each other without breaking. Okay, yep. Heavy metal tungsten alloy, they are around 95% pure tungsten mixed with nickel and copper. Explain why heavy metal tungsten alloy is harder than pure tungsten. Okay, so this is what we discussed before. Let me find the picture. Yes. Okay. Yep. Okay. Yep. Okay. Yes. Okay. So this one, pure tungsten. So this is 100%. Okay. Tungsten. So when we apply the force, the atoms can slip past each other easily. Okay. But when we mix with nickel and copper, okay, when we have alloy, they get stuck, okay? So they cannot move past each other easily. Different atom size will impede the atom slipping, okay? So they cannot slide over each other easily, okay? Okay, in an alloy, there are atoms of different sizes, okay? Atoms of different sizes, it is more difficult for the atoms to slide over each other, okay? So they cannot slide over each other easily. Okay, so the tungsten alloy is harder, okay? So in general, metal alloys, they are harder. Okay, next. Explain why the interior of the light bulb is filled with argon gas. Okay, so normally inside the light bulb we fill with argon gas. Okay, argon gas is inert. Okay, it's non-reactive. Okay, it's non-reactive. Why? Argon is here. Okay, group 8. Okay, so if we look at the protons, okay, electrons, electron configuration 288. Okay, so it's already having the full shell. Okay, it's already having the full shell, so it does not react. Okay, so it does not react. We call it non-reactive. We call it inert. Okay, so this is very important for the light bulb. Why? Okay, because if you have oxygen inside, the oxygen will react with the tungsten. Okay, we don't want that. We want the tungsten metal. We don't want it to react with oxygen. So we will put inert gas inside. Yeah, okay. Okay, yeah. Because argon gas is unreactive, it does not react with tungsten. So it will increase the lifetime of the filament. Yeah, so the light bulb can be used for longer. Okay. Aluminium forms oxide when it reacts with oxygen. Okay, so we form Al2O3, just now we mentioned. The oxide has a giant ionic lattice structure and protects the aluminium from corrosion. Okay, okay, let me find a picture. Okay, aluminium oxide. Okay, okay, yes. Uh-huh. Okay, yep, okay. Okay, so this is the situation here. Okay, so this is our aluminum metal. This is aluminum 0. Okay, aluminum metal. Okay, but if it's not protected, it will straight away form Al2O3. Okay, it will straight away form the metal oxide. Okay, but if on the surface it's got a layer of aluminum oxide, okay, it's got one layer of aluminum oxide, the oxygen, it cannot go inside. Okay, oxygen cannot go inside, so the aluminum, it still can remain as metal. Yeah, okay, so it still can remain as metal. So that's how this aluminum oxide is acting as the protective layer. Okay, chemical formula of oxide, we know that Al3 plus Al3 plus, and then oxygen, 3 of them. Okay, so this will give -6. This will give +6. So that's why the correct formula should be Al2O3. Yeah. Okay. Why aluminum oxide has a high melting point? Because it is ionic compound, right? Because it's ionic compound. Okay. A lot of energy is needed to break the strong ionic bonds. between the oppositely charged ions. Okay, so these oppositely charged ions, they are strongly attracted together. Okay, positive and negative charge. So we need a lot of energy to break the strong ionic bonds. Okay. State one application of aluminum oxide. Okay, so what is it useful for? Okay, because of the high melting point. Okay, high melting point, it can be used as refractories, ceramics, abrasive. Yeah, okay. Okay, one chemical that can be used to remove the oxide layer on the surface of aluminum metal. Okay, so this one, let's say we want the aluminum. We don't want this layer of aluminum oxide. What can we do? Okay, we can put acid. Okay, so the acid can remove the oxide layer. Okay, next, carbon dioxide is a simple molecular compound that formed by combusting carbon and oxygen gas. Okay, draw the dot and cross diagram to show the covalent bonding in the carbon dioxide and oxygen gas. Okay, yeah. So first, carbon group 4 is having 4 outer electrons, so it will form 4 bonds. Okay, 4 outer electrons form 4 bonds. Okay, to share 4 electrons and then get 4 electrons. Yeah, okay. So it's going from 2, 4 to 2, 8. Okay. So oxygen is 2, 6. So it's going to 2, 8. Okay. So 6 outer electrons, 1, 2, 3, 4, 5, 6. Okay. So it needs to share 2 electrons, get 2 electrons in the process. Okay. So it will form 2 bonds. Okay. So let's look at oxygen first. Okay. So we know oxygen is O2. Why? Because of this. It will form this molecule. 1, 2, 3, 4, 5, 6. Okay. And then the other one. 1, 2, 3, 4. Okay. 3, 4, 5, 6. Okay. So that's why oxygen is always O2. Okay. It forms the double bond. Okay. Oxygen, oxygen, double bond. It's sharing 2 pairs of electrons. Okay. Okay. How about carbon dioxide? Okay. How does it work for carbon dioxide? Okay. So carbon, it needs to form 4 bonds. Okay. Okay. It needs to form 4 bonds. Oxygen needs to form 2 bonds. Okay. So the most suitable arrangement is like this. Okay. Carbon, 4 electrons from carbon, and then oxygen, 6 electrons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah, okay. So it forms double bond like this because sharing 2 pairs of electrons. Okay. Yeah. So like this. Okay. Why carbon dioxide is a gas at room temperature? Okay. Because this what we mentioned just now. Yeah, these weak intermolecular forces. Okay. So weak intermolecular forces, low melting point, low boiling point. Okay, because of the weak intermolecular forces. Low melting point, low boiling point. That's why it is a gas at room temperature. Okay. Yep. Okay, so there are weak intermolecular forces between the carbon dioxide molecules, which do not require a lot of energy to overcome. It's easy to overcome the attraction. So carbon dioxide is a gas at room temperature and pressure. Okay, next. Diamond and graphite, they are allotropes of carbon, okay, one type of carbon. They have similarities and differences, okay, in the properties and structure. Okay, compare the bonding and structure. Okay, yeah. So what we have here, yeah, okay, similarity and the differences. Okay, let me just copy quickly. Yep. Okay, two similarities and two differences. Okay, so we can discuss about that. Okay, two similarities. Okay, covalent bonds form between the carbon atoms. Okay, they form covalent bonds. Okay. What else? They form macromolecules. Okay, they form macromolecules or giant covalent structure. Yeah. Okay. So similarities, differences. What's different about them? Okay. So for the graphite, each carbon form three covalent bond. Yeah, this one has weak intermolecular forces between the layer, weak intermolecular forces. For diamond, each carbon atom form four covalent bond, forms tetrahedral structure. Okay, so this is what we call tetrahedral structure. Okay, so that's the concept. Okay, next. Okay, explain in terms of structure and bonding why the graphite is often used as electrode. Okay, but not diamond. We talked about this before. Because it's electrical conductor, it has the localized electrons. Another application of graphite, we discussed that, is lubricant. Okay. Why diamond has higher melting point than ice? Okay. Because diamond is giant covalent. Okay. All the carbon atoms in diamond, they are held together by strong covalent bond. Okay, need large amount of energy to overcome. But molecules of water, they are held by weak intermolecular forces. Yeah, what we mentioned just now, this one. Weak intermolecular forces for the ice. Okay, so which need less energy to overcome, less energy. Okay, next. HOCl is a good sanitizer that kills bacteria, virus, algae, and yeast. Okay, it is simple covalent compound with strong covalent bond. Okay, define the term covalent bond. Okay, what is covalent bond? Yeah, so I'm going to go like a little bit faster because we only have 6 minutes left. Okay, 2 page remaining. Okay, yeah, I'm going to try to go a bit faster. Okay, yeah. Covalent bond, electrostatic forces of attraction between the nucleus and shared pair of electrons. Yeah, okay. So attraction between the nucleus and the electron. Yeah, so the nucleus is positive charge, electron negative charge. So that is the attraction. Okay. Yeah, need to memorize that. Okay, complete the dot and cross diagram below to show electron arrangement. Okay, so hydrogen is 1, oxygen is 6, okay, chlorine is 7. Okay, so how do we arrange it to make it work? Okay, so it's like this. Yeah, okay. So oxygen 1, 2, 3, 4, 5, 6, and then hydrogen is 1, and then chlorine 7. Yeah, okay. So in the end, 8, 8, 2. Okay, it works out. One physical property of HOCl, simple molecular structure, low boiling and melting point. Okay. Next. Okay, sodium nitrate, NaNO3, dissolve readily in water but not in hexane. in the solid state is not electrical conductor, but conduct electricity in molten state. No problem, because it's ionic. Okay, so these are properties of ionic compound. Electrical conductivity in the solid and molten state. Okay, so what's the difference there? Okay, in solid state, it is a non-conductor because the ions, they are not free to move. Okay, molten state is electrical conductor because now the ions, they are free to move. Okay, it's already melted. The bonding in sodium nitrate, okay, ionic bonding. Okay, it is ionic bonding, electrostatic forces of attraction between oppositely charged sodium and nitrate ions. Okay, state the formula of the anion that is isoelectronic with sodium ion. Okay, isoelectronic means same number of electrons. Okay, so first, sodium. Okay, so if we look at sodium atom, okay, proton 11, electron 11, electron configuration 281. Okay, so it will lose one electron to form sodium ion. Okay, so now proton is still 11, electron is 10, so electron configuration is 28. Okay, so electron configuration of sodium ion is 28. Okay, what are other anion that is also 28? Okay, so our answer is this. Okay, why? Let me give example. Okay, fluorine is 27. Yeah, 27. It will add one more electron to become 28. Yeah, fluoride. Okay, oxygen is 26. It will add 2 electrons to form 28. Oxygen 2 negative. Okay, nitrogen 25. It will add 3 electrons to form 28, to form the nitrogen anion. Okay, so this is the concept of isoelectronic. Okay, they all end up with 28. That's what we mean by isoelectronic. Okay, so quickly finishing the rest. Okay, dot and cross diagram of nitrogen like this. Why? Okay, nitrogen triple bond. Okay, because nitrogen is like this. Okay, 5 outer electron, it needs to form 3 bonds. Yeah, okay. So it needs to share 3 pair of electrons to get full shell. Yeah, okay. Nitrogen, okay, react with hydrogen to form ammonia. Okay, state the source of hydrogen gas. Okay, so I'm just going to go a bit quick. Okay, get from natural gas and petroleum. Balance chemical equation, nitrogen gas and hydrogen gas. Okay, like this, no problem. Okay, dot and cross diagram. So this one we discussed before. So it's going to be like this. Nitrogen form 3 bonds. Okay, hydrogen form 1 bonds. Okay. Okay, chemical that can be used to convert ammonia to ammonium salt. This is not that important. Okay, strong acid. Okay, yeah, with this, we finish everything. Yeah, okay. So all the questions on this worksheet. Okay, so again, I already record the video of the class. If you want to, you can come back and watch all of this, okay, before your test. Okay, so yep. So time is perfect. We can stop now. So today we done the chemistry revision and then biology revision on Friday morning, same time. Yeah. Okay. So anything you just text me, any question, anything you just text me. And then yeah. So on Friday we will do the biology revision. Can you tell me which topic of biology for your test? Which topic?
Oh, I'll send you in WhatsApp.
Okay, can. You send me later. I will prepare. Okay, so if no other question, we stop here. Okay, see you on Friday. Okay, thank you. Bye bye.